I'm going to go over a couple of them on your worksheet 7.5a. The first one I'll do with you is number 7, and I'm not going to do many at the beginning, and I'll head to towards the end here pretty quickly for those of you who got some done in class. So the first one we'll start with is number 7. So make sure you have that out. You might want to write by 1 through 7. Those are all where you're trying to get the same base. So you might want to, there's a couple more along the way too, but these are all ones where we get the bases the same so we can set the exponents the same. So on number 7, on the left I have a base of 2, and on the right you're given a base of 4. When you're trying to decide the common base, usually it's pretty apparent. When you see 2s and 4s and 8s and such, those are all powers of 2. So my common base would be a 2. So on the left-hand side, I won't do anything. But on the right-hand side, 4 is 2 to the second power. So we'll write it like that. We're going to replace 4, and rewrite it as base 2. We still raise it to the x plus first. Once you have the common base, remember that when you do power to a power, you multiply the exponent. So again, the left side is holding steady here. The right side becomes 2 to the 2 times x plus 1, which gives you 2x plus 2. Once you get the same base, you can set the exponents equal. So you could say 3x is equal to 2x plus 2. And then we're down to Algebra 1, just solving a simple equation. And we'll get x is equal to 2. And that's the answer to number 7. The next one we're going to do together is number 9, right below it there. On number 9, I can't write 19 as a power of 2 or as a power of 4. So if I were to ask you 4 to what power is 19, we don't know that. So that's where we need to use our natural log properties. And you should have been told that you take the natural log of both sides What that allows you to do is get that x out of the exponent by using the property that says it comes out front. So we have x times the natural log of 4, which is some number. You could go to your calculator and see what number it is if you'd like to, but you don't need to, is equal to the natural log of 19. Just like if I had 2x equals 8 and I'm solving it for x, I divide both sides by 2. Over here, what's in the way is the natural log of 4. So I divide both sides by the natural log of 4, right? Not so bad. Your calculator will need to do that for you. So you'll have to take out your calculator. So you might want to pause, go grab a calculator, whatever. But your natural log button is 2 up from the on button. So you'll hit LN19. Make sure you close it when you enter it. So it'll have a bracket here when you hit that button. Make sure you close it before you hit divide by natural log of 4. And that'll be what you write. I don't know what you were told to, oh, it says round to 4 decimal places up at the top. So you should round your answer to 4 decimal places. We're cruising right along here. Let's skip ahead to number 11. We have 5 just sitting out by itself, minus 3 to the x power, equaling negative 40. Before we can start this one, I know I'm going to need to get that x up in the exponent, but before I can do that, I have to get everything that's in the way out of there. So I've got to get that 5 out of there first. It's a positive 5, so you'll subtract it from both sides. And you'll get a negative 3, or the opposite of 3 to the x would be negative 40 minus 45. Right here, I divide both sides by negative 1 to get rid of the negative. It'll get rid of it on both sides. So we'll do 3 to the x power is equal to 45. I can't write 45 as a power of 3. 3 to the second is 9, 3 to the third is 27, 3 to the fourth is 81. I can't get the same base. So I have no choice but to take the natural log of both sides of the equation. What that allows me to do is bring the x out front, get it out of the exponent. So I'll rewrite that as x times, you can put it in parentheses or put a little dot. I actually like the parentheses better, so we'll do that. X times natural log of 3 will be equal to the natural log of 45. And then again, this natural log of 3 is a number, and I'm multiplying by it. So to get rid of it, I will divide both sides by the natural log of 3. I'll go to my calculator. These will cancel over here on the left. Over on the right, I'll go to my calculator using that natural log button that's 2 up from the on. Make sure you close that parenthesis right there before you hit divide or it'll do it wrong. And you're supposed to go out to 4 decimal places. So again, make sure you count 4 decimal places out. The next one I'll do is number 15. For number 15, I've got a piecewise function and I'm trying to solve it. And so I'm going to use the substitution property. In the bottom piece I have that minus 4 to the x minus 1 equals 0. And there was a y sitting right here. But the first piece tells me what y is. It says it's 2 to the x plus 4. So the first thing I'll do is substitute in. Next step, I will get these set equal. Now this one doesn't need the natural log because both this base, 2, and this base, 4, are powers of 2. So I'll leave the left-hand side as is, and I'll write the right-hand side as 2 squared. That's what 4 is, right? To the x minus 1. And again, the reason I do that is because if I can get the same base, which I actually have once I multiply these exponents, remember if you were to do 2 to the third to the fourth, that's 2 to the 12th. We multiply those exponents. So that's my next step. I'll multiply those and get 2 to the 2x minus 2. Now that I have the same bases, they don't cancel out, but you can picture that they do because I'm allowed to set the exponents equal. And again, the reason I didn't need, the reason I didn't need the natural log on these is because I could get a common base. Had this been the number 3 right there, then I would have had a 3 here, and then I would have had to go natural log because I can't write 3 as a power of 2. But this is nice and slick because the 4 was easy to work with. So we'll solve that. We'll get 4 equals 2x minus 2, and you guys are capable of solving that on your own, that's for sure. All right. So then, what do we have next? We have number 17 will be the next one that I do. So scooting up to one of the word problems here. For number 17, as a town gets smaller, the population of its high school decreases by 6%. The senior class has 160 students right now. That's kind of like with your money. This is how much money I have, how many people are there. It will decrease. So that model from the first part of the chapter would tell you to do 1 minus the percent. It's decreasing 6% each year. The senior class has 160. In how many years, remember that's the exponent, we've been calling that t in the previous part of the chapter, will it shrink down to 100. My goal is to solve this for how many years? So I need to get rid of this 160 first. So we'll divide by 160, divide by 160. You have your calculators, but I don't have one on me, so I'll just do this by hand. I'm going to divide out a 10, and then I think I'll divide out a 2, and I get 5/8 over here on the left. If you want to put the decimal for 5/8, that's totally fine. And then this right here, you can either leave it or go do it on your calculator, or say if I lose 6%, I keep 94%, whatever floats your boat, but that ends up being a 0.94 to the t. Now, this obviously I can't get the same base. There's no way I'm writing 5/8 with the same base as 0.94. So I have no choice but to take the natural log of both sides. So I'll take the natural log of the left, and I'll take the natural log of the right. Remember, the reason that we do that is so we can disengage this variable from the exponent and plop it right in front. That's one of our 3 rules that we have. So I have the natural log of 5/8, so you might have made that a decimal, totally fine, is equal to t times the natural log of 0.94. And again, my goal is to figure out how long that would take. This is actually a very applicable skill in the real world for people who do city planning, for people who work with money, just because it helps us solve for a particular time when a quantity is reached. It's actually one of the more applicable skills in the real world of all the stuff you've been doing. This one's used by quite a few professions. Anyway, you would go to your calculator and divide by what was in the way of the t, which was ln 0.94. I don't have a calculator on me, so you'll have to wrap that up, and it doesn't say what to round to, it just says in how many years, so I think we'll have to round up for that if we need to have full years. So flipping to the next page, we'll go to a couple in the review, and I'm only going to go to 15 minutes, so let's go look at number 20. Number 20, log base 1/2 of 8. I'm supposed to evaluate that without my calculator. So I would set it equal to x. Remember I told you base to the outside is equal to the inside. It spells boy. So I'd have 1/2 to the x, base to the outside has to equal 8. This is where I go get that common base, and I can see those 2's embedded in here. 8 is 2 times 2 times 2, or off your orange sheet, you'll choose 2 to the third. 1/2 is 2 to the negative 1. So if I had to show my work, that's what I'd show. Now that I have a common base, I can set the exponents equal, and that'll help me solve for x correctly. So number 20 is done. Second to the last one up, number 24, using those log properties of the last couple days to condense the logarithm. So I have a 1/3 out front, and then I have a log with a base of 2, plus another log with a base of 2. And remember, addition condenses to multiplication. So the first squish on it I would do is make this log base 2 of 3a. I'd just go like that. So 1/3, I'm going to even put my parentheses over here now. It'd be 1/3 of log of 3a. Remember, this gets to come in as an exponent as well. So when I condense it completely, I'd have log base 2 of 3a, all of it to the 1/3. It's important that that 3a is in parentheses because this was in front of the whole thing, not just in front of one of them. So you need to lock and load that in a set of parentheses. And I'm going to be very close to my 15 minutes here. Last one, number 26. This is a review from 6.5 where you're solving radical expressions. And remember, we said that first thing we need to do to attack this x is get that power out of the way. You guys were good at this. You all would tell me raise it to the reciprocal power. So I'll do that on the right-hand side and on the left-hand side. What that does is give you 10 over 10, and it wipes out that power. And I get x minus 1 equals 4 to the 5/2. Now, if you want to use your calculator for that, that's fine, but the root is on the bottom, so I know that that's actually a square root of 4, which is 2, to the 5th is 32, but you're probably going to want to use your calculator. Then obviously we add 1 to both sides, and look at that, I'm at 14 13 and counting with 1, 2, 3, done seconds. Awesome.